Hello, my name is Mohammed Professor. My project name is Tool Band Rectangular Patch and Number CXK Band Applications. My team leader is Sai Sri, and my co-teammates are Yamuna and Supriya. Contents of my project is abstract object groups introduction, literature survey, design methodologies, design parameters, and design result, conclusion, and reference. Abstract. Agnostic patch and provides a number of characteristics makes them a variable positions for microwave communication. Two novel designs for SCK band applications are proposed in this study. For SC band applications, the first design were presented. For CXK band applications are second design was offered. The first antenna is in this study as triple band at 3.3, 4.4, and 6.3 GHz, which are classified as SE bands. At 7, 10.7, 16.1 GHz, the second antenna in this study has triple band and then designated as CXK bands. Size of first antenna is 28 into 23 mm square size. The size of second antenna is 24 into 20 mm square size. Retinal loss of two proposed antennas is less than -10 dB. The patch antenna designed for computer simulated and optimized using HFS software.
To get good to explore and develop the required to improve an antenna is a structure usually made from we have field line is connected.
Literature survey. These are the papers which we are studying for designing our antenna. Design methodologies. Selection of design parameters, modeling of antenna structure, simulating and optimizing design parameters, testing of antenna, comparison and result evaluation. Design parameters, return loss, gain, radiation pattern. Return loss, the loss of signal power due to reflection or return by the discontinuity in a fiber optic link or a transmission line is known as return loss. Return loss equal to 10 log 10 P out by P. Gain. Antenna gain indicates how strong a signal an antenna can send or receive in a specified direction. Radiation pattern. A radiation pattern defines the variation of the power radiated by an antenna as a function of the direction away from the antenna.
Coming to our first antenna design, this is our first antenna design, and this is the ground structure, and this is the patch structure. Here we are having a rectangle. We are having three kind of rectangles, and we just added these three rectangles, and we have inverted U-shape notch in this antenna. Now coming to the return loss results, these are the return loss results of our antenna 1. Here we are having three kinds of operating bands. So this is one operating band, this is another operating band, this is another operating band. So we can say that these three are the operating bands and these two are the stop bands. Now coming to VSWR, this is the VSWR result of our antenna 1, and the radiation pattern at 3.3 GHz is this. Now coming to the radiation pattern at 4.4 GHz, this is the radiation pattern of antenna 1 at 4.4 GHz. This is the radiation pattern of antenna 1 at 6.3 GHz. Now coming to gain, this is the gain of our antenna 1, and these are the current distributions of antenna 1 at different kinds of frequencies. So this is 3.3 GHz frequency, this is 4.4 GHz frequency, and this is 6.3 GHz frequency. So these are all the current distribution results of our antenna 1. Because of the large structure of antenna 1, we are going to propose a new antenna in which the size of the antenna is less than the size of the antenna 1. So this is our antenna 2 design, and this is very easy to design, and it is not as complex as our antenna 1. So this is our second antenna design, and the S11 results of this antenna is this. Here also we are having 3 operating bands. Coming to VSWR, this is the VSWR results of our antenna 2. And as I already mentioned, here we are having 3 kinds of operating bands. So the first of radiation pattern of antenna 2 at 7 GHz frequency is this, and the radiation pattern of second antenna at 10.7 GHz is this, and the radiation pattern of the second antenna at 16.1 GHz is this. Now the gain of this antenna is this. The current distributions at 7 GHz, 10.7 GHz, and 16.1 GHz is presented like this. So when we are going to the conclusion, here we are reducing the size of antenna, and here we are having some kind of frequency ranges, and we are increasing the bands. The same time we are having return loss, and the same time we are having VSWR. So these are the references. And thank you. Now we are going to show the implementation of our final project software model of our antenna 2. This is our antenna 2 structure, and now we are going to show you the results of our antenna. This is the S11 result of our antenna, which is nothing but the radiation pattern. Sorry, return loss. This is the realized gain of our antenna. This is the radiation pattern. As I already mentioned, we are having 3 bands, so we have radiation patterns at three kinds of frequencies. This is our another radiation pattern. Now coming to the current distributions. This is about the current distribution of our antenna at one frequency. This is another frequency, and this is of another frequency. So this is about our second antenna design and our results of the antenna. Thank you.